You poured the absolute perfect mix. You finished it beautifully, but the lab just called and your concrete cylinders failed the strength test. Again, bad breaks don't just cost you time, they cost you massive amounts of money, project delays, and your reputation. But here's the secret. 90% of the time, your concrete is fine. The problem is how you cured your test cylinders. Welcome back to Certified MTP, your ultimate source for material testing equipment and expertise. I'm your host, and today we are tackling one of the most frustrating, headache-inducing problems in the construction and concrete industry, the dreaded bad break. When a concrete cylinder fails to meet its required compressive strength at the 7-day or 28-day mark, the immediate reaction is almost always to blame the ready-mix supplier. Everyone assumes it was a bad batch of concrete, that the water-to-cement ratio was off, or that the mix design was flawed from the start. But in reality, if you are working with a reputable supplier, the mix is rarely the issue. The stark reality is that the vast majority of low-strength test results are caused by improper initial curing on the job site. If your samples are left sitting out in the blazing summer heat, freezing overnight, or vibrating next to heavy machinery, they are never going to reach their true strength potential. You are essentially testing abused concrete, not the concrete that is actually in your structure. And that abused concrete is going to give you a failing grade every single time. Before we get into the solutions, we need to talk about the real-world consequences of a bad break. Let's say your 28-day cylinder breaks at 3,200 pounds per square inch when the project specifies 4,000 pounds per square inch. What happens next? First, the structural engineer gets involved. Construction on that section of the project comes to a grinding halt. You cannot pour the next level, you cannot strip the forms, and your entire timeline is frozen. Next comes the destructive testing. You now have to pay an independent firm to come out to the site, drill core samples out of the actual poured structure, and test those. Coring is incredibly expensive, time-consuming, and leaves permanent patches in your finished product. If the cores pass, congratulations. You just spent thousands of dollars and lost a week of work to prove that your concrete was fine all along, and that your initial curing was just terrible. If the cores fail, you might be looking at tearing out the concrete and starting over. All of this chaos, all of this financial drain, simply because a plastic mold full of concrete wasn't kept at the right temperature for the first 48 hours. It is an entirely preventable disaster. To understand why proper curing is so critical, you have to understand a little bit of the chemistry. Concrete doesn't dry. It cures through a chemical reaction called hydration. When cement meets water, crystals begin to form and interlock. This interlocking matrix is what gives concrete its immense compressive strength. Hydration is incredibly sensitive to temperature and moisture. If the concrete gets too cold, the hydration process slows down dramatically. If it drops below freezing, the water inside expands, permanently destroying the internal structure. On the flip side, if the concrete gets too hot, the reaction happens too fast, and the moisture evaporates before the interlocking crystals can fully develop, leaving you with weak, brittle concrete. This is exactly why the American Society for Testing and Materials established ASTM C31. This standard clearly dictates that for the first 48 hours, standard concrete test cylinders must be stored in a temperature range of exactly 60 to 80 degrees Fahrenheit or 16 to 27 degrees Celsius. Furthermore, they must be protected from moisture loss. You cannot just leave them under a piece of plastic or in the back of a pickup truck. If you do not follow ASTM C31, your tests are invalid, period. You are setting yourself up for failure. So how do we fix this? How do we completely eliminate bad breaks caused by poor field curing? The answer is incredibly simple. You take the environment out of the equation. You need professional, reliable curing boxes that guarantee your samples stay within that perfect 60 to 80 degree window, regardless of what the weather's doing outside. Today, we are going to look at 3 elite solutions available right now at Certified MTP that will protect your samples and protect your bottom line. First up is the PerfaCure Elite Mini Concrete Curing Box. Think of this as your ultra-portable, bulletproof insurance policy. Not every job site is pouring massive high-rises. Sometimes you are doing residential flat work, small commercial pads, or localized repairs. You might only be casting a few test cylinders. The Elite Mini is designed specifically for these scenarios. It is incredibly lightweight and easy to transport. meaning your testing technicians can move it from site to site without breaking their backs. But do not let the mini name fool you. This box packs the exact same heavy-duty, rigorous temperature regulation technology as the larger models. It features automatic temperature control that monitors the internal climate continuously. If the ambient temperature drops, the heating elements kick in gently. If the sun is beating down on it, it actively cools. It ensures your samples stay perfectly within the ASTM specifications, giving you precise, reliable breaks every single time without taking up valuable footprint on a crowded job site. Next, let's talk about the heavy-duty winter warrior, the 𝐕𝐴 Elite Concrete Curing Box, heat-only, 34-gallon model. If you are pouring concrete in the dead of winter, or if your projects are located in regions where the overnight temperatures consistently plummet, this is your ultimate workhorse. This unit doesn't feature cooling, because frankly, in winter climates, it doesn't need to. Its sole mission is to aggressively fight off the freezing cold. With a massive 34-gallon capacity, it can handle multiple sets of test cylinders from large continuous pours. Inside, it blankets your samples in a consistent, thermostatically controlled heat. This ensures that the hydration process never stalls and that the internal water never freezes and compromises the cellular structure of your samples. If winter weather is your biggest enemy on the job site, this heating-focused curing box is the ultimate defense mechanism. Finally, we have the flagship model, the top tier of climate control, the Concrete Curing Box 𝐶𝐞+3. This box is designed for the contractor or testing lab that refuses to compromise, no matter where the job site is located. The 𝐶𝐞+3 handles both active heating and active cooling, providing absolute, uncompromising environmental control. Whether you are pouring a bridge deck in a scorching 100-degree summer heat wave or casting columns in a freezing winter blizzard, the 𝐶𝐞+3 actively monitors and adjusts. It utilizes advanced thermal technology to either draw heat out of the box or pump warmth in, locking the internal temperature perfectly within that critical ASTM 60 to 80-degree window. It is rugged, incredibly durable, and built to withstand the harshest job site conditions while protecting the most delicate phase of your concrete's life cycle. When failure simply isn't an option, the 𝐶𝐞+3 is the box you rely on. Now, you might be thinking that operating advanced thermal equipment is complicated, but that is the best part. Explain how to use these three products? I can do it in 4 incredibly simple steps. You do not need a degree in thermodynamics to operate them. Stop losing money on bad breaks. Stop letting poor field curing delay your projects and damage your reputation. By investing in a 𝐕𝐴 Elite Mini, a 34-gallon heating box, or the advanced 𝐶𝐞+3, you are guaranteeing that your concrete test results reflect the true strength of your hard work. To completely eliminate failing test cylinders from your job sites, click the link in the description below to visit Certified MTP and get the perfect curing box for your next project today. Make sure you hit that subscribe button for more expert material testing solutions. Drop a like if this video helped you, and we will see you on the next one.